nanopencil, right? So as I say that nanotechnology can be multidisciplinary. Why? Because if you have a piece of photoresist, electron resist, a quantum polymer, if you apply electric field strong enough between this polymer and the nanotubes, it will form a discharge, electron field, all the way ground to the trying ground to the substrate down there. If you do that, you can use this nanotube to scan it so that the electron will irradiate on the spot that you want in a nanoscale. So it becomes a nanopencil, right? You can write the word here nanotubes, nanopencil, in a scale of less than 1 micron meter. Okay? Chemical and biosensing, right? So imagine that at the end of the probe here, if you can attach a molecule down here, okay? And if this molecule can recognize what is the molecule down here on the substrate, then you can differentiate what is the chemical on the substrate. Imagine now you have a DNA, single-strand DNA line at the bottom of the substrate. And now on the other side of your probe, you have another complementing DNA, single-strand DNA. If you scan through them, it will recognize spot that having a complementary single-strand configuration. Then you change your probe to another type, etc. If you scan that, you can map the DNA sequence. But that will take million years. Okay, electronic devices. As I told you, it's a multidisciplinary area, right? You are not only working on the materials. You can apply this to electronic devices. You can use these devices for many other sensing, astrophysics detection, okay, elementary particle detection, etc. Well, just to skip the details, just simply tell you that nanotubes can be a different band gap with different orientation of the atoms, right? I just told you. So this is the first transistor ever made, FET transistor ever made by using carbon nanotubes, right? It takes months to build this for the first device. Now say it still take days. So how are you going to build billion pieces of the tubes of chips for your microprocessor? It will take you how many years? I don't know. So this is the challenges right now. You might be able to build a device based on 1 piece of nanotubes, 2 pieces of nanotubes. But how are you going to integrate this to a full-scale functional devices? This is another assignment for you, young physicists, for the next 10 years. All right, you can even use this as a sensor. Why? As we say that this is a nanotube, right? You fold this up. You can see that all the atoms are lying at the surface. Inside is hollow. So if you have electron flow, electron will flow on the surface, not inside the hollow area, right? So when electron flowing, it will touch the electron, touch the surface. What will happen? The electron might flow to your fingers. Or now change it the other way. If you put another molecule in, right? And this molecule, let's say DNA or antibody, okay? And now you have another protein coming in. If this protein can recognize the antibody, it will bind to the antibody, right? So the charge from your protein will transfer to the tubes, or other way around, from the nanotube transfer to the molecule. So this can be used as a sensor, right, to detect molecules. Okay, so this is the fun thing about nanotubes in this case. And in this case, the example shown here is based on the so-called silicon nanowire, right? In principle, you can do the same for silicon or for carbon nanotube as well, right? So if you do that, you can see that initially no molecule attached to the sensor, the current just flow, the conductance doesn't change, right? So when suddenly you have something that is specifically recognized by the antibody, the conductivity will change, right? So it gives you a way to sense toxic materials, or even imagine that next time in a chip, you can have, don't say million, let's say 100 types of sensors that can recognize different diseases. You just need 1 drop of your blood on the chips. The doctor can tell you, maybe a few minutes later, whether you are infected by this one of the 100 types of disease or not. Okay? So this is nanotechnology. You don't have to draw 100 bottles of blood to test for 100 types of disease, right? You just need 1 drop. So hopefully this is the so-called green technology that raised by Professor Masan as well. Okay? So you can imagine that why we talk about green. Nowadays, everything based on silicon, right? You have to build a whole ingot of single crystal. You slice them to wafer, and then you do photolithography anyway. Take away all the unwanted structures, and then you left the microstructures. This much of materials, left this much of materials for your devices. This is wasted energy. What happens if you use atoms? Build them from atom level to form a microstructure. So this is the so-called bottom-up approach. The traditional way that we are having now is top-down, from big one, chop down, not small one, top-down. Okay? So this is the difference between nanotechnology and the so-called conventional technology. Flat panel display, you know, TV, most of you spend most of your time on TV, internet, video game, but after a while your eyes will be very tired, right? And you spend a lot, when you go to your electric, when you receive an electric bill, you feel painful, right? So nowadays, you can use nanotubes to form very small display. So just like here, you have nanotubes sticking out here, right? And then this is one of the, what we call cathode, right? And on top here, you have the anode, where on the anode, you can coat with different fluorescent materials, red, green, and blue. Okay? So in that case, you have the red, green, blue pixel here. By applying voltage at the appropriate dot, you will extract electrons from the nanotubes to bombard on red, green, or blue at one time. So basically, you have nano electron gun that can show you the color on the screen. So that is your TV, the display. Right? Next time, you can talk to your PNC and say, oh, I have a new display. Come on, let's go for barbecue. What are you holding? This is my TV. 2 pieces of plastic, nanotubes on the bottom, and a glass with the fluorescent coating on top. Then you have the power supply. This is your TV. You can hang on the tree during your barbecue. You can watch whatever you want. Okay? So this is just the promises. This has been talking about more than 10 years. We still did not see any products out there. Okay? So if you see something in 1 year, don't buy. Okay? Wait. They have reliable product. Okay, this is a demo unit of the so-called nanotube X-ray gun. Now say if you have something else, you want to see what's happening inside your body, you go for X-ray detection, right? And you have to go to a special room. The machine is even bigger than you or bigger than the car, right? So now say you can change. Why? A little bit of plasma physics, right? You have the carbon nanotubes here, and then you apply the anode to accelerate the electron to a speed that you want, so that this energetic electron will strike on the target material, can be molybdenum, can be copper. And when you do that, if the energy of the electron is enough, if you knock the core electron out, right, and the valence electron will decay back to the core to emit the X-ray. So if you have this case, then you have a handheld X-ray gun. You can scan your fingers if you have any injury or whatever. You can see all the fish bones and the fingers of animals here, right? All right. I hope I have convinced you that nanotechnology is promising. Okay, it might change the way that we live in the future, right? And however, there are many challenges remain for you to solve, because I'm getting old. All right. Any question? So I hope you feel excited, you feel interested, and you feel like trying to explore into this area. You are lucky because in this department you have many researchers involved with nano research. All right. Quick example, Dr. Roslan sitting down there. All right. I just put your photograph up there, right? And you cannot imagine he's no, this is not nanotubes, right? You can test the strength if you want. Ask for some sample. So these are nanotubes brought in his lab, okay? If you're interested, talk to him, all right? He's also interested to field emission. I have started helping university develop a technology to measure electron field emission that might allow you to build future flat panel display so that you can convince your friends